Greetings, Globeheads and Flerfers. What's up? No, that's not a greeting. I already gave you my greeting. That's a real question. What's up? I mean, other than something Rick Astley's never going to give you. I asked this question, what's up and what's down, because it seems like flat earthers really have a hard time understanding up and down. I'm not sure they even know. How many times have you heard the flat earther argue that the globe believers somehow believe that people are hanging upside down in Australia? Or that if you go to the other side of the earth, you should see buildings and people upside down? Or even claim that if the globe model is reality, then some rivers have to run uphill. Do you really think that north is up and south is down? Because that's how we decide to hang our maps or globes, which is kind of just a random thing. What is up and what is down? Down is the direction of the pull of gravity on a globe. That's toward the center of that globe, period. Toward the ground. How can water stick to a spinning ball? It won't. It'll get pulled to the ground. That's what gravity does. Here's the thing about debunking someone else's model. If you're going to debunk it, you have to understand it. If you're going to destroy it, you have to describe it properly, because otherwise what you're destroying is something called a straw man. You cannot attack the globe by making statements that no globe believer believes in and then explaining why those statements are wrong. Okay? Nowhere in any globe model is anybody in any part of the earth ever going to be upside down. Because by definition, no matter where you are located on the globe, you are standing on top of the globe with the entire globe beneath you. Gravity is a method by which matter attracts matter toward the center of mass of that matter, with a force relative to the combined mass of the two objects. Did you know that technically the moon does not orbit around the earth? The moon and the earth, in their total mass, orbit around the center of mass of the earth and the moon. Now, since most of the mass of the earth-moon system is made up of the earth, the center of mass of those two objects is located within the earth, but not at the center of the earth. Therefore, as the moon orbits around the earth, or rather the moon and the earth orbit around this center of mass of the two, the earth wobbles. The sun even wobbles because of its planets. Now, in a very minor way. I don't know what the percentage is, but a very large percentage of the solar system's mass is in the sun. But there is a wobble. It's enough that we have been able to, that's how we first detected what we call exoplanets. These are planets that are part of solar systems other than our own. And we've found these first by detecting the slight wobble of their stars and predicted based on that amount of wobble where this planet was, how big it was, how far it was away from the star. We first did this without ever seeing these planets. Now, another method that they use is that they can actually see a drop in the light slightly coming from a star as one of these planets transits across the face of that star. But that's how we found these planets. So if you're going to criticize the flat Earth or the globe Earth model, what many of us like to call reality, make sure you understand it first. Nobody's upside down in Australia. You don't have to go uphill to go over a hump in the sea or whatever. Sea level is sea level all the way around the globe, because it's all based on the center of mass. And while we're at this argument that flat earthers keep making about, oh, it's not gravity, it's density and buoyancy. Let me ask you this question. We know that the gravity, we know that the density of air, for example, is higher at sea level, and air is less dense as we go up. By the time we get to the top of Mount Everest, we can't breathe on our own. We have to carry oxygen canisters if you're going to climb to the top of Mount Everest, because the air is so thin. So my question is, if density and buoyancy is the only thing that makes things fall, then why do they not fall up? If they fall because the air below them is less dense than the object, but the air above is less dense than the air below, why would they fall down instead of up? And if you believe that there's just some universal down direction and things just go there, what force drives them there? Density and buoyancy aren't forces. So what's up? What do you really believe constitutes up? Why is there an up? Why is there a down? Explain that. Because as soon as you get rid of gravity, I can think of no reason why there would be an up and down. So what's up? There's a lot of fun to be had out there on YouTube. But don't fall for the snake oil salesman out there.